transients, DC transients. We will proceed with one more problem. This is the question, you can see. This is the question. A circuit is given. You have to find I1, I2 and the derivatives. Only first order derivatives is enough. Okay. Now what I will do, at t equal to 0 minus, switch open. At t equal to 0 minus, switch open. Okay. Draw the circuit. When switch is open, draw the circuit. What happens? This is the voltage, and here resistance will be there, and here resistance. It is a closed circuit, so inductor will act as short circuit. Current flows in the inductor. Okay, this is short circuit. Current flows in the inductor, and then current flows in the inductor, and voltage also exists in the capacitor. So capacitor acts as open circuit. Okay, this is R1 value, this is R2 value, this is R3 value, this is supply voltage V, and this is the circuit at t equal to 0 minus. Okay, the reason is current flows when switch is open. Means here switch is open. Okay, so there is a closed path exists. So I1, it exists, and here we are bothered about voltage in the capacitor at 0 minus exist. Okay, wherever capacitor is there, we should be bothered about voltage. Wherever inductor is there, we should be bothered about the current. Okay, VC exist, and the current in inductor exist. Current in inductor at 0 minus exist. This is our concept when switch is closed. Okay, this IL is nothing but I1 only. I1 of 0 minus only, it exists. Okay, voltage exist means it acts as open circuit. Capacitor acts, this is the reason capacitor acts as open circuit, because voltage exists, some current is flowing and voltage is developed, so it is acting as open circuit. Okay, this is the reason why inductor is acting as short circuit. Okay, now we will try to find out what is that current in the inductor. When switch is open? So we have a closed path, so V by R1 plus R2 is the closed path. So values are given in the problem itself. V value 100, and R1 value 10 ohms, and R2 value 20. Okay, this is 100 by 30, which is 3.33 is okay, 3.33 amperes. Okay, before switch is closed, this is the current flowing. Now what about voltage in the capacitor? What is the voltage in the capacitor? What I can do, the parallel branch where current flows, so I1 of 0 minus is flowing in R2 resistor, that is a parallel branch to capacitor. That voltage I can take it as voltage across capacitor. This I1 of 0 minus is nothing but IL current only. Okay, IL current at 0 minus only, and R2 resistor. So 100 by 30 is the value. R2 value is given in the question 20. Okay, R2 value given in the question 20. So 10 will get cancelled. 6.67 into 100, which is nothing but 67 volts. 67 volts. Okay, this is about switch open. Okay, now I am going to the right side. When switch is closed, what happens? When t equal to 0 plus switch is closed, what happens? So we will have the switch, but inductor and capacitor will not allow sudden changes. Okay, so here switch is closed, and then R1 resistor will no longer be present in the circuit, and R2, R3 will be present. Capacitor will still act as open circuit. Inductor will still act as short circuit. Okay, inductor short circuit, capacitor open circuit, because sudden changes are not allowed. Okay, they will still behave the same, and this is the supply voltage P. Now this closed loop, current I1 is there. Okay, Here open circuit is there and R2, R3 resistances are present. These are R2 resistor, R3 resistor. Okay. Now I will retain the same voltage and current values. So here current in the inductor is same. Current in the inductor IL of 0 plus is same, which is 100 by 30. Same value. Okay, though R1 resistor is present or not, that is not the issue. But same current will flow in the inductor because sudden changes not allowed. This is initial condition only. We are not in steady state. In steady state means this circuit we have to operate and find what is I1 value, that is at steady state t equal to infinite. Okay. Now I'm talking about initial condition. So IL of 0 plus is 100 by 30 only. 100 by 30. And VC of 0 plus same voltage exists, 667 volts. 667 volts. Okay. This is it correct? 3.33 into 20 I am writing. Into 20 I am writing. 20 means 66 should come, no? Into 20. 100 by 30 is there. 100 by 30 is correct. 100 by 30 into R2 value. 1 0 cancel. 2 by 3. 2 by 3, 66. Here I have written wrong. This is 0.667 into 100. 0.667 into 100. So 66.7. Okay, the value is 66.7. So it is 66.7. Simplification I have done wrong. 66.7 volts. Okay. Now we will proceed. Voltage and current 66.7 and 66.7 volts. Okay. Now this is the initial condition. Now we will go with the steady state. Write some KVL equations based on that. Okay, first the initial currents completed. Initial currents completed. Because it is open circuit in the second branch. I will talk about I2 current also. Okay. In the circuit it is given I2 representation. So I will talk about I2 current here. I2 current at 0 minus, we will take 0, and we will not tell about I2 current at the steady state. Now at the initial condition, I can say I2 current at 0 plus also 0, because these two go together. Okay, in the capacitor branch we are discussing. Now I am moving ahead. At steady state, what happens? This circuit holds good at steady state. Steady state means t equal to infinite. Now for t equal to infinite, we will write the equations. Okay. Left side switch is open. Right side switch is closed. Now same circuit valids at a steady state also. Steady state, this circuit, okay, capacitor, inductor will act not as short circuit, open circuit. They will come into picture. Okay. The same circuit I will go with at steady state. I will modify short circuit, switch is closed, R, inductor, and then this resistor and capacitor. C value, L value, this is R2 value, this is R3 value, and supply voltage. Okay, circuit changes like this for steady state. The circuit modified for the steady state. Now you write the KVL equations. Here current I1 will be flowing, and I will take this outer loop as closed loop. I2 current I will take here. or I will take the current. I need current in the capacitor branch. Okay, I2 or I. Now I will write the KVL equation. I am going at t equal to infinite, voltage, resistor, inductor, another resistor, capacitor. This is CL, R2, R3, and then V. What I am trying to do, I will take current I1 in this closed loop. In this outer loop, I am taking supply also into picture. Outer loop, I will take I2. Okay. Inner loop, I will write KVL. Inner loop, I will write KVL. Supply voltage equal to R2 into I1 plus L into di1 by dt. This is equation 1. When you make di1 by dt as subject, it becomes V by L minus R2 by L into I1. Okay. All the values are available in the given question. V value 100, L value 1 Henry. Okay. 100 and 1 Henry minus R2 value 20. R2 value 20 and L value 1. 20 by 1. And this is I1. Okay. This is di1 by dt. When you calculate this at 0 plus, what happens? This becomes 100 minus 20 times I1 current at 0 plus. Okay. What is the answer? What is the answer? 100 minus 20 into I1 of 0 plus. We already calculated I1 of 0 plus. This is I1 value at 0 plus. This is I1 value at 0 plus. 100 by 30, 3.33. Okay. So I will take 100 by 30. 100 by 30. So this becomes 100 minus 2 by 3 times. 2 by 3 times 100 means 66.67, which becomes 33.33. Okay, ampere per second. Ampere per second. This is inner loop completed. Now I will go with outer loop. I will go with outer loop calculation. I will go with outer loop calculation. KVL for outer loop. KVL for outer loop. Okay. So outer loop, I have V supply voltage R3 into I2 plus 1 by C integration I2 dt. Let this be equation number 2. Okay. Now what happens? If I differentiate this, 0 equal to R3 di2 by dt plus 1 by C I2. Okay. Let this be equation 2a. If I not required, 2a not required, equation number not required, equation number next line I will give some equation number. So here I will make di2 by dt as subject. Okay, what happens? Minus 1 by r3c into I2. I can take this, I can give a number 2a. Now this 2a I will calculate at 0 plus. This 2a I will calculate at 0 plus. It becomes minus 1 by R3C into I2 of 0 plus. I2 of 0 plus. Okay. So what happens? I2 of 0 plus we got 0. I2 of 0 plus we got 0. 0 plus. So whether I have minimized this. It is working. Here I want to make a small change. Okay. Here I want to make a small change. This currents I will not make it 0 as it is because voltage exists. Voltage is developed because of some current flow. Voltage is developed because of some current flow. Okay. That current I will identify. That current I will try to find out. If you see what is that value, Here I am telling some voltage is developed. Some voltage is developed in the 0 plus. Here I am telling Vc of 0 minus, Vc of 0 plus. This voltage is 66.7 volts. 66.7 volts developed across capacitor. Here across capacitor voltage is 66.7 volts, 67. Okay, 66.7 or 66.67 volts voltage is developed. Okay, now I will write some KVL equation for finding I2 value. For finding I2 value, if I take this outer loop as closed path, I2 current, I am trying to find I2 current. That I2 can be calculated as V minus Vc of 0 plus divided by R3. I can calculate like this, okay? Because straight away current I cannot make 0 because there is some voltage developed in the capacitor. Some voltage is developed in the capacitor. So V value 100 minus this Vc value 66.7 divided by R3 value given in the question, which is 20. Okay. So this becomes 33.33 divided by 20 is the I2 value at 0 plus. At t equal to 0 plus, this is the current. Okay. At t equal to 0 plus, this is the current in the second loop. So that current I have to take here. So minus 1 by R3C into what is that value? 33.33 by 20. 33.33 divided by 20. Already the values are given in problem. R3 value 20, capacitor value 1 microfarad. R3 value 20, capacitor 1 micro 10 power minus 6 into 33.33 divided by 20. Okay. So what happens? To simplify this, minus 10 power 6 by 20 into 20 is there. Okay. Then 33.33 is there. 100 by 20 is 5. Another 100 by 20 is 5. Another 100 is left out. Okay. 100 into 33.33 becomes 3333. Okay. 3000. For simplification purpose, whatever you want, you do it. 33.33 into 100 I will write as it is. When you simplify this entire thing, what happens? Okay. 33 into 5. 30 into 5 is 150. 150 into 5 is 750. 750 into 100 becomes 75,000 approximately. And it is more than, because I have taken 30 approximate. It is 33 actually. 33 actually, which is 155 into 5. 165 into 5, 165, then another 75, 825, 825 double 0, 825 double 0, approximate answer minus. Okay, approximately I will write minus 825 double 0 ampere per second square. This is first order derivative for I2 current at 0 plus time. Okay, so you can see here in the question what they are asking: actual currents I1, I2 and their derivatives. Derivatives means only first order derivatives we have found. Actual currents I1 of 0, we have 100 by 30. I2 we are calculating using the KVL because voltage is developed in the capacitor. Straight away we cannot write I2 current is 0 because there is some voltage developed. Some small initial current had been flowing for which voltage is developed. Okay, and that current I2 of 0 plus we calculated on the right bottom. It is 33.33 by 20, and we applied KVL for inner loop, calculated the first order derivative for I1 current 33.33 ampere per second. KVL for outer loop, we have calculated the current I2 current at 0 plus, and the value is minus 82500 ampere per second. Okay, so this is about the DC transients. This is about the DC transients problems.